Let's take a look at a couple of examples now. Let's start off with the polar function r of theta equals cosine of theta. So when theta is 0, cosine of 0 is 1. Pi over 6, cosine of pi over 6 is root 3 over 2, which is approximately 0.86. Pi over 4, cosine of pi over 4 is root 2 over 2, which is approximately 0.70-ish. Cosine of pi over 3 is a half. Cosine of pi over 2 is 0. Cosine of 2 pi over 3 is negative 1/2. Cosine of 3 pi over 4 is negative root 2 over 2, which is a negative 0.70-ish. Cosine of 5 pi over 6 is a negative root 3 over 2, which is approximately negative 0.86. And of course, cosine of pi is negative 1. So with this, we can take a look at the graph and see what it's going to be like. Well, when theta is 0, I'm out here at 1. So I'm right there. At pi over 6, which is roughly here, I'm at 0.86. Let's see if this is 0.5, 0.75, roughly 0.25. Okay, so 0.86 is somewhere like in here. At pi over 4, it's roughly pi over 4, I'm at 0.7, so right around there. At pi over 3, which is roughly here, I'm at a half, so right around there. At pi over 2, which is obviously straight up, I'm at 0, so I'm right here. So I'm coming around like this. And then let's see, where am I now? At 2 pi over 3, I'm at negative 1/2. So at 2 pi over 3, my angle is like this. But my radius is negative 1/2, so it's 1/2 in the other direction. So it's going to be like over here. At 3 pi over 4, roughly out like this, is 3 pi over 4, I'm at negative 0.7. So I'm going to be roughly here, the opposite direction. At 5 pi over 6, roughly that angle. The radius is negative 0.86. I'd be coming back again, so roughly here-ish. And then at pi, when I'm over here, the radius is negative 1, so I'm back here. So an artist I ain't, but again, that's a circle. So cosine of theta is a circle here. And sine of theta was a circle that looked like this. Okay, let's take a look at secant of theta. Secant of 0, and remember secant is equal to 1 over cosine of theta. Secant of 0 is 1, because that's 1 over cosine, and cosine of 0 is 1. Secant of pi over 6 is 1 over root 3 over 2, which is approximately, let's say, 1 over roughly 0.86, which is about 1.16-ish. At pi over 4, I have 1 over root 2 over 2, which is 2 root 2 over 2, or just root 2, which is 1.41-ish. Pi over 3 is, cosine of pi over 3 is at 1/3. I'm sorry, is 1/2. So I have 1 over half, which is 2. And at pi over 2, cosine is 0, so I get 1 over 0, which is undefined. Let's stop there and see what we've got. Well, if I look at this, at 0, I'm at 1. So right here is 1. So when the angle is 0, I'm right there. At pi over 6, it's an angle something like this. I'm at 1.16-ish, so somewhere in here, I guess. And then at pi over 4, which is an angle like this, I'm at 1.41-ish, which is, I don't know, somewhere up in here, I guess. Let's go ahead and actually try to figure out what those values actually are, because I'm just kind of guessing where it's going to be. Actually, it's arcing back, so it probably should be more like that, or maybe more like this. When we get to pi over 2, remember this is the radius is undefined. So as I get to pi over 2, this is pi over 2, my radius is going to be undefined, but prior to that it's going to be approaching infinity. It's going to get, obviously huge. So where is it actually going to in terms of this graph? Well, let's take a look at just this one for a second. If I have this triangle, and I know my radius is 1.16, and I know this angle is pi over 6, what I really want to know is what is cosine. Okay, what is this? Well, we know that cosine of theta, well, let's just do it like this very quickly here. On the unit circle, if I have a triangle where this is 1, then cosine of theta equals x over the radius 1, so we relate cosine with x. Okay, so that means that cosine of pi over 6 equals x over 1.16. Now that would then mean that x is equal to 1.16 times cosine of pi over 6. Okay, but what is this 1.16? 1.16 is secant of pi over 6, correct? So x is actually equal to secant of pi over 6 times cosine of pi over 6. Because remember the radius here, or right here, is actually secant. But secant's 1 over cosine. So this is cosine of pi over 6 over cosine of pi over 6, which is obviously just 1. So this x coordinate is 1, so it shouldn't be over here, it should be straight up. Oh, let me get a red one. Now if we keep doing that for all these other angles, I'll get the exact same thing. Regardless of what angle I get, it's going to be straight up. So in other words, r of theta equals secant of theta. I didn't draw it very good because, in case you haven't figured out by now, I'm not very good at drawing, but that's the vertical line. And I went from 0 to, well, I didn't go to pi over 2 because that's undefined. I stopped at roughly pi over 3. But if I have, say, negative pi over 3 to pi over 3, then I'm going to have a line segment that looks like this. So let's go ahead quickly here, and let's jump on to Maple and take a look at a couple of these. So first thing I want to do is take a look at cosine of theta between 0 and pi. And I'm going to make the thickness 4 so it's really nice and just kind of jumps out. There it is. That's that same circle that we just looked at. Now I'm going to do polar plot. And this time I'm going to do secant of theta. And theta is going to equal, I'm going to go negative pi over 3 to pi over 3. And this should give me a line segment. Now obviously I can't go to pi over 2 because Maple's going to have a heart attack if I try to tell it to draw a line actually to infinity. It's not going to know what to do with it. Oops, didn't like something. Oh, let me see what it is here. Oh, the comma. There we go. And see, there's my line segment. Let me make it nice and thick so that you can see it. 4. So there's that nice thick line segment. And as you see, as I increase my angle, I'm always going to be at the x coordinate of 1, so the segment's just going to get longer and longer and longer.